2011 war ein sehr ereignisreiches Jahr für das DLR.
2011 was a very eventful year for DLR, the German Aerospace Center. We have made progress in all areas of our operations to meet today's global challenges. In aviation, we tested new landing approach procedures with our A320 Atra. We installed an electric nose wheel, which enables a plane to taxi using electricity powered by fuel cells. And we made advances in aeroplane cabin technology. We also saw the successful launch and delivery of the ATV-2, Johannes Kepler, to the International Space Station, where we also installed the AMS, using the penultimate space shuttle flight. We saw the successful launch of 2 Galileo satellites, the first components of a European satellite navigation system. In the transportation sector, I would like to mention AIM, the application platform for intelligent mobility based in Braunschweig. In the energy sector, we are now able to better pursue solar energy research with the purchase of the solar tower Jülich. The topic of security has shown itself to be ever more important. We were able to observe the Fukushima catastrophe from space and thus able to give tips to rescue workers. We are also planning to address maritime security. I am delighted that we finally have a complete and comprehensive executive board, with which I am sure the German Aerospace Center will be able to meet all future challenges.
Scientists from Airbus and the German Aerospace Center DLR in Göttingen tested a new ventilation system for the first time. 63 dummies went on the simulated flight. Lasers were used to make airflows visible. The Advanced Technology Research Aircraft Atra was still in the hangar. A week later, it was time to take to the air for a 4.5-hour flight. This time, 12 human volunteers were on board as well. Their job, to assess the comfort of the new system. It relies on displacement ventilation, in which cooled air is introduced from the floor. The expected benefits were confirmed. The orbital towing service was heading for another defunct satellite. Scientists at the German Space Operations Center continued their efforts to use the European Proximity Operations Simulator, EPOS, to develop methods to capture, move and steer satellites. Such a service could extend satellite life for years. At the testing facility, factors such as solar radiation, weightlessness and contact dynamics were simulated. These all influence such maneuvers. Final assembly was carried out on the automatic transfer vehicle ATV-2 Johannes Kepler at the EADS Astrium facility. The ATV-2 can do more than its predecessor. It has 2 cubic meters more usable space and can carry an additional 300 kilograms of cargo. It was launched from the European spaceport at Kourou in French Guiana. The craft's destination was the International Space Station, the ISS. DLR's Space Administration oversees Germany's role in the ATV program. After a nearly 8-day flight, the Johannes Kepler docked with the International Space Station on February the 24th, 2011. On board the ATV was also the German experiment GeoFlow 2, with which the flow behavior of fluids is being researched. The German Space Operations Control Center in Oberpfaffenhofen near Munich took charge of the Swedish satellite mission PRISMA. During a 5-month period, DLR held responsibility for the mission and had the opportunity to carry out experiments in space. PRISMA was launched in 2010 and consists of 2 satellites called Mango and Tango. The purpose of their mission is to demonstrate independent satellite formation flights in space, as well as to prepare for future inspection and repair missions in orbit.
Bereitstellen.
Car travel could begin like this in the future, without a driver. FastCar is a test vehicle for a driver and virtual co-pilot. They help each other out on the road. The system can slam on the brakes for the driver when danger is imminent. FastCar has been developed by the DLR Institute of Transportation Systems. Take a look into the heart of a gas turbine at the Stuttgart Institute of Combustion Technology. The high-pressure combustor rig Stuttgart, or HBKS, was used under real operating conditions, as it would be by an energy supplier. By using state-of-the-art laser measurement technology, flames were analyzed at high temperatures and pressures. Space junk has long been recognized as a threat to active space missions. Now a laser-based system is being developed to locate defunct satellites and help avoid collisions. Since the beginning of spaceflight, the amount of junk has increased greatly. That's why scientists at the Institute for Technical Physics in Stuttgart are continuing their work to develop ways to monitor space junk. As a member of the DLR Executive Board, Dr. Gerd Gruppe has been responsible for the Space Administration in Bonn since April 2011.
The Space Administration in Bonn is the main contact point for all agencies of the world, including, of course, in Europe. We have contacts with people from NASA to JAXA, and we see ourselves as the platform in the right place between politics, economics and science. The main task I have set for myself is to better prepare the Aerospace Center, the Space Administration and Germany's space program for the future. I personally believe we should concentrate on cultivating our ties with future space program partners in Eastern Europe. That is a very important field. Germany's space program today has already taken the lead position in many areas around the world. I see this primarily in our Earth observation program, but also in areas like robotics, and above all in areas like science and astronomy, as well as in research and the constraints of working in space. We must keep this position as well as build on it, and the Space Administration in Bonn will play a large part in this.
The Space Shuttle Endeavour took its final flight. En route to the ISS were the Alpha Magnetic Spectrometer, or AMS, and the external payload platform, the Express Logistics Carrier. The AMS is equipped with several particle detectors designed to investigate cosmic radiation. Its purpose is to answer basic questions about matter and the origin and structure of the universe. It's being funded by Germany's Federal Ministry for Economics and Technology.
Your touchdown.
The shuttle returned after a successful 16-day mission.
Houston, Endeavour, we'll stop.
Goodbye, Endeavour. German President Christian Wulff and the State Premier of Lower Saxony, David McAllister, visited the DLR Institute of Composite Structures in Stade. Here, DLR is researching components that are made of carbon fiber reinforced polymers, or CRP. Those who can master lightweight construction technologies have a competitive advantage in aviation. DLR's automotive engineers set up their first crash test. At the Institute of Vehicle Concepts in Stuttgart, groups of components are being tested under real conditions. A crash sled weighing tons is accelerated along a length of 1.5 meters from 0 to 64 kilometers an hour in just seconds. A big pressure cooker took to the road. DLR has the world's biggest research autoclave. With a length of more than 27 meters and weighing in at 165 tons, it's used to carry out research on large aircraft components, such as fuselages, wings, and tail units. It was on its way to Stade. This car drives independently as well. It's the Havit car from the DLR Institute of Transportation Systems in Braunschweig. A button is pushed and it's time to let go of the wheel for independent overtaking. But the driver is still responsible for the car and can override the automatic systems at any time. The world's biggest research autoclave arrived in Stade via the Dortmund-Ems Canal, the Rhine, the Ems and the Weser rivers, the Mittelland Canal and the Elbe River. The trip took more than 2 weeks. It also required closing the A26 motorway as it made its way to its destination. At the end of 2011, the autoclave was to be adjusted, tested, and brought into operation. It works like a pressure cooker in which materials form compounds under high temperatures and pressure. On June 15, 2011, Professor Hans-Jörg Dittus was made a member of the DLR Executive Board, responsible for space research and technology.
We have set ourselves some major goals in space flight. The challenge is how we prepare ourselves for the future. That will certainly be one of the biggest issues, as well as how we can improve our consulting skills. The second major area is the development of technological abilities in space robotics. We also have to explore new paths in research. One of the main areas of focus will be advances in the science of spaceflight as a whole. A fourth area is being faster in the construction of satellites. We simply have to improve our turnaround times. I see Germany's space program taking a leading role in 10 years, together with our European partners and also within the international community. We have to set the trend in spaceflight. If we succeed in doing that, then we have achieved a lot. It depends how we strengthen the cooperation between the different fields of research. Spaceflight can contribute a lot to the field of energy research. We know this from our Earth observation program. We will also have a lot of overlapping areas with aviation. In the future, this will also be the case with transportation, because the monitoring of international traffic patterns is an important topic, especially the satellite monitoring of air and ship traffic.
DLR's Airbus 320 research aircraft ATRA carried out an unusual taxiing maneuver. A fuel cell powered two electric motors located in the rim of the nose wheel. A nose wheel like this could drastically reduce noise and exhaust emissions at airports. At Frankfurt Airport, for example, emissions could be reduced by 17 to 19%, and noise during taxiing by almost 100%. Or put another way, it would save some 44 tons of aircraft fuel per day. A 47-ton aircraft taxis to the runway on electric power. The Falcon research aircraft went on a birthday flight. Whether it's Spitsbergen in Greenland, the tropics, or the southern tip of the Americas, DLR's Dassault Falcon 20E research aircraft has gone to all corners of the globe in the service of science. For 35 years, the Falcon has flown for DLR. Perhaps its most famous flight was in April 2010, as the Icelandic volcano Eyjafjallajökull erupted and grounded air traffic in Europe. It was the only aircraft to make a number of measurement flights. Retirement is still a long way off. The German Aerospace Center took over operation of the Solar Energy Tower power plant in Jülich. The pilot facility is to be used more intensively for research. DLR solar energy experts are to work here developing and testing new components aimed at making solar power plants more efficient and less expensive to operate. The Jülich facility is also an example for future power plants in Southern Europe and North Africa. A skier strives for the ideal position. Athletes from the German Paralympics national team tested their alpine skiing in the wind tunnel at the Technical University Hamburg-Harburg. The wind was blowing at 130 kilometers per hour. Little research has been done into the optimal positioning for physically handicapped athletes. Researchers at the DLR Institute for Aerodynamics and Flow Technology in Göttingen worked in cooperation with sports doctors to measure drag force, lift force, and pitching moment. At the Plataforma Solar de Almería in southern Spain, DLR energy researchers brought a new test facility into operation. The device can turn almost 360 degrees. As a result, the efficiency of the parabolic reflector can be exactly calibrated at every possible angle. The sun's rays that are concentrated by the reflector were used to heat thermal oil in an absorber pipe to 400 degrees Celsius. Energy researchers can use the new testing facility to simulate how parabolic reflectors are used in power plants and thereby increase the degree of efficiency of the entire plant. It's not fiction, but reality. The DLR Institute for Transport Research in Berlin has joined forces with Volkswagen to conduct a major experiment on a completely new drivetrain concept, twin drive. The car can be propelled either by an electric or internal combustion engine. A computer coordinates how the two engines work together. Large stretches can be traveled under electric power. It's as efficient as can be, and the combination increases the vehicle's range. The DLR Institute of Space Systems gained an important new research facility. In the new laboratory building, research satellites and landing systems will be integrated and tested, and control systems for space vehicles will also be designed. The Institute is involved in the research and development of complex space flight systems.
Thank you very much, and now I give this symbolic key, which is more of a tile, to the Lord of the Manor, Mr. Dittus.
Sophia made its first visit to Germany when the world's only flying observatory touched down at Cologne-Bonn Airport. Sophia had set off from California at night to observe the stars. The Stratospheric Observatory for Infrared Astronomy, or SOFIA, is a joint project of NASA and DLR. In the infrared spectrum, stars coming into being can be seen even if they're surrounded by clouds of matter. With SOFIA's help, researchers aim to increase their understanding of how galaxies develop and how stars and planetary systems come into being from interstellar matter. The Flying Space Observatory was installed in a specially modified Boeing 747. The infrared telescope that was built in Germany is located behind a hatch.
The organizations, NASA and DLR, have natural peaks and valleys in terms of their budgets and their funding. And fortunately, the two organizations have always been out of sync. So when NASA was having a little bit of trouble financially, DLR was okay. And then maybe if DLR was having some financial problems, NASA was okay. So we were able to kind of compensate and balance for each other. So it's really been a fantastic partnership. It's really brought to the table, in my opinion, the strengths of each organization in a very synergistic way to accomplish this really fantastic project.
It was time for open house at the DLR site in Cologne. Tens of thousands of visitors came to learn more about the science of tomorrow. They could take a peek into control rooms, see a satellite up close, and get up close to astronauts. Under the patronage of German Economics Minister Dr. Philipp Rösler, DLR hosted the 11th Air and Space Day. Minister Rösler introduced Germany's next astronaut.
ESA has now made the decision, and I would like to expressly thank ESA for choosing Alexander Gerst as the next German astronaut, who will fly to the International Space Station over Christmas in 2014, and will be making an extended stay there. I wish you much success, good fortune, health, and may God bless you. I am looking forward to it. It is a terrific time, particularly because I am working together with the people who got me this far with the training, with the colleagues from the European Astronaut Centre and DLR, who've all been so committed to this training, to this dream that we all have of flying to space.
A number of DLR institutes are working on the Va Bene project, which is aimed at developing ways to best manage traffic at large events. The whole Va Bene system was tested for the first time at Air and Space Day. It was a rehearsal for the real thing, which took place in Bonn 2 weeks later on October the 3rd, the day of German unity. DLR scientists supported Bonn police in gathering both air and ground traffic data. These data were then collated at a mission control center and published on an online portal designed by DLR. Preparations were made for an experiment at the Arctic Circle aboard a Bexus balloon. This was one of 20 experiments conducted by student teams at the S-Range Space Center near Kiruna in northern Sweden. The students received technical and logistical support from scientists and engineers from DLR, as well as the Swedish Space Corporation. The balloon rises to an altitude of up to 35 kilometers and makes flights of 2 to 5 hours. The payload is returned to Earth by parachute to be picked up by a helicopter and given to the students for evaluation. The Kourou European Spaceport in French Guiana. Launch preparations were underway for both of the first Galileo satellites. The building of an independent European satellite navigation system was about to get off the ground. The satellites were carried into space aboard a Russian Soyuz rocket. With the start of Galileo, Europe has taken a significant step in establishing a purely civilian navigation system of its own. It's also ensuring jobs for the future. The high precision of Galileo signals will make new navigation applications possible. In the coming years, a total of 30 satellites will be launched to orbit the Earth and provide precise positioning data on the ground. A premiere. On October the 21st, 2011, the first liftoff of a Soyuz rocket went off without a hitch at Kourou. At the supersonic wind tunnel in Göttingen, a model of an unmanned flying wing is being prepared for an experiment. It's an aircraft that consists only of a wing. The design is a real challenge for aerodynamic engineers because it has no tail or elevators. In the wind tunnel in Göttingen, the research is carried out at speeds of up to Mach 0.8 to see how air eddies influence the craft's flight. The findings will be of great significance in designing and developing unmanned aircraft in future.